Okie dokie, guys, 7-2 part 2. Now we're going to look at dividing the radical expressions, your second objective from today's lesson. All right. This is the first example today, but it's example 4 from the section. Just like with multiplying radical equations or radical expressions, you have to have the same root. You can't do square root divided by cube root, fourth root divided by cube root. It has to be the same root. It also has to be possible for you to take the root of whatever the number is. Like that first example we had from part 1, we could not take the square root of -4, so therefore we knew it wasn't going to work. Okay. All right, so let's take a look at our examples. Divide and simplify, assume all variables are positive. We love that part of it. It makes our life easier. Okay, cubic root of -81 divided by the cubic root of 3. I have found that it's a lot easier, at least for me it was. I know that cubic root over cubic root means that it's just one big cubic root of -81 over 3. Now, you test to see if -81 is divisible by 3. 1 plus 8 is 9. 9 is divisible by 3, so yes, you know it is. And in fact, this is going to give you the cubic root of -27. Now, if you don't remember, you can do your prime factorization. And remember, because we're looking at the cube root, we want groups of 3. So we have cubic root of -3 times -3 times -3. Since we have a group of 3, this is just equal to -3. Now, of course, there's a little bit more of a shortcut there if you recall that, and you don't have to go through the factorizing, the prime factorization at all. Okay, over here, cubic root of 192. 1 plus 9 is 10, 10 plus 2 is 12. 12 is divisible by 3, so 3 does go into 192 evenly. And in fact, that's going to go into it 64 times. So we're going to go ahead and rewrite this first. So we've got the cubic root 192 x to the 8th over 3x. Okay, so 3 cancels out because 192, 3 goes in 192, 64 times. This is x to the first, and remember when we divide exponential expressions, we keep the base and we subtract the power. So 8 minus 1 is going to give us 7. So simplifying this, we have cubic root of 64 x to the 7th. Hopefully you know the cubic root of 64 is 4, but if not, I hate to do it this way. Just memorize cubic root of 64 is 4. It'll make your life easier and everything else. So I'm going to bring this out front. 4 cubic root of x to the 7th. Now the other way to think of this, and I kind of mashed up the methods on that first video, is to ask yourself, okay, how many times does 3 go into 7 evenly? Well, 2 times, and I'd have 1 left over. So you'd have 2 x's out front, and you'd have 1 left underneath. So looking at this, cubic root, we want groups of 3. So we've got 1 group of 3, we've got 2 groups of 3, and then there's 1 left over. So we bring those x's out front, and we have 4x squared cubic root of a single x. And that is it. All right, let's go ahead and go on to the next one. Rationalizing the denominator. This was always one of my favorite things to do. Don't know why, it just was. Except for when we got down to problems like C. Hated it. Hated it. But I'm going to do my best to explain it to you in a way that makes sense. All right, so rationalize the denominator of each expression. Assume that all variables are positive. Okay, we cannot have a radical in the denominator. It is not proper form, it is not good mathematics, so we do what's called rationalizing it. And what that means is we want to get rid of the radical in the denominator, and the easiest way that we know to get rid of that is to multiply it by a value that would get rid of that square root. So what times the square root of 5 would give you an integer, would get rid of that radical? The easiest thing we found is to just do square root of 5, especially if this is a prime number. Okay, so multiply that by square root of 5. Now, what you do to the bottom, you have to do to the top. Otherwise, you will be unbalancing your expression. And this is just another way to write 1, because square root of 5 divided by square root of 5 is 1. So now in the numerator, since those are both square roots, we have square root of 15 over 5, because square root of 5 times square root of 5 is square root of 25. Square root of 25 is 5. Easy peasy. All right, now let's take a look at B, which is a little bit more complex. And we have x, square root of x to the 5th over square root of 3x squared y. Now, this guy right here is just screaming at me to be taken care of, right? But I've also got an x to the 5th up top. So I'm going to bring these together first, do it as one term. So we have x to the 5th in the numerator. We have 3x squared y in the denominator. 5 minus 2 is going to give us 3, and that cancels out. So now we have square root of x cubed all over square root of 3y. 3y is prime. There's nothing else I can do with that. So I'm going to multiply it by the square root of 3y. And what I did to the bottom, I have to do to the top. So now in the numerator, we have 3x cubed y, square root of 3x cubed y, all over 3y. We're not quite done. We still have one thing left to do in order to say that this is simplified, and that's to look at this x term. We have a cube underneath a square root, so that means we can pull something out. This is the same as x times x times x, right? And we're looking for a square, so that means we want a pair. So we're going to pull that pair out, bring it out front, and we're left with 3xy. So this simplifies to x square root of 3xy all over 3y. Now, ugly, messy, it is tedious. It is a lot of steps that you have to take, but at the same time, it's definitely worth it. All right, C. Now we have our game changer, the cube. Okay, so this means we need to have groups of 3. It can't just be 2. You can't just multiply by 1 and then you have a pair of 2. You have to have the groups of 3. So sometimes that means you have to multiply it by 2 of whatever that value is. All right, so I'm going to expand this out, and we have cubic root in the numerator. It's just a 5. In the denominator, I'm going to rewrite 4 as 2 times 2 times y. Okay, so we are looking for groups of 3 and just whatever is in the denominator, right? And whatever we have in the denominator, this is just going to be a fancy 1. So we have 2 2's. That means I want a third 2. So now my 2's would group up. I have 1y, so I want 2 y's. And I would want 2 y's up here. However, instead of writing it as 2 times y, I'm going to go ahead and do 2y squared. All right, same thing. But now the 2's group up and the y's group up. So in the denominator, we have 2y. In the numerator, we have cubic root, 5 times 2 is 10, and then y squared. Now, neither of those factors are able to take the cube root, so this would be our final answer. Okay. All right, I think there's one more example. Yep, it's the word problem, and then we are done. All right, the distance d in meters that an object will fall in t seconds is given by d equals 4.9 t squared. Express t in terms of d and rationalize your denominator. All right, so we're wanting to solve this for t. So we have d equals 4.9 t squared. First step, divide both sides by 4.9. Now that cancels out. And we have, I'm going to rewrite this so that my variable is on the left. The one I'm solving it for, t squared, is d divided by 4.9. I take the square root of both sides, and I'm going to move this up here for more space. We have t equals, I'm just going to leave it like it is right now, d over 4.9. Please do not be tricked into thinking that that would be 0.7. In order for you to have a square root of 49, it would either have to be pure 49 or 0.49. 4.9 is not going to give you the square root of 0.7. All right, so I am going to multiply this by the square root of 4.9, and I'm also going to do it up here. So now I have in the numerator d times 4.9, so we have the square root of 4.9d all over 4.9. Now you can leave it just like that, or you can go ahead and take that square root of 4.9 and get a value. But this would be the easiest and the least amount of work necessary. All right, that is it. Hopefully that has made some sense. Have a wonderful day.